Hello everyone, welcome to our YouTube channel Metallurgical Engineering. So in this video we are going to discuss one problem on phase diagram. In our previous lecture series of physical metallurgy we have discussed about tie line and this lever rule and also about phase diagrams. From that we can if you have seen that video you can easily solve this kind of problem. So in this problem, it is saying that the binary phase diagram of this for copper nickel alloy is shown below. So here you can see the phase diagram of this binary phase diagram of copper and nickel. So on the x-axis you have weight percentage of nickel, and on the y-axis you have temperature here. And also if you can see the some important things, like if you can see the melting point of copper here, that is this 1084 degree, and you can see the melting point of nickel is given, which is uh, 1455. And another important thing, if you can see these two line, which is called liquidus and solidus line. So liquidus line is the region this line between liquid phase and liquid plus solid phase, which is alpha here. So this line is called liquidus, and this solidus line is the line between liquid plus alpha and uh, alpha. And for this alloy it is given the overall composition, which is 30 weight percent of copper. So 30 weight percent of copper means 70 weight percent of nickel, because if you can see here at this extreme left, which is 100% of copper, so it means 0% of nickel here. And here if you can see 100% of nickel means 0% of copper. So it is like this. So some important questions, if you can see the melting point of pure copper that we just talked about, 1084 degrees Celsius. Melting point of nickel, which we just talked about here, if you can see 1455 degrees Celsius. Weight percent of nickel in the entire binary alloy, which just taken the 30 weight percent of copper, so 100 minus 30, which is 70 weight percent of nickel. So the answer is 70 weight percent of nickel. The two phases present at this composition and temperature. So if you can see at this at this composition, which is 30 weight percent of copper or 70 weight percent of nickel, and 1350 degrees Celsius, this one. So in this region, if you can see, you have two phase, alpha plus liquid. So liquid plus solid, which is L plus alpha. So the answer is L plus alpha. Now the next question is the weight percent of nickel in liquid phase and weight percent of nickel in solid phase. So you have to identify the composition of this one in liquid phase as well as in solid phase. So you have to draw the tie line at this temperature. So this tie line is cutting at liquidus and at solidus here. So at liquidus it is cutting around 61% of nickel, and at solidus it is cutting at 73 weight percent of nickel. So for this, the weight percent of nickel in liquid phase, so which is getting it at this liquidus, so liquidus line. So the answer is 61 weight percent of nickel. While for weight percent of nickel in solid, which is 73 weight percent of nickel. Now, so this hatch can so these things can be determined using tie line. Now the next question is weight percent of alloy in the liquid phase and the solid phase. So for these two things you have to apply the lever rule. So basically if you can just see here as from there, so this is given as 61, this is given as 73, and this is the overall composition, which is 70. So here we are talking about in terms of nickel weight percent. So if you have to identify if you have to determine the weight percent of liquid phase, so for liquid phase you have to take the this thing, so like 73 minus 70 divided by, so weight percent of liquid to overall 73 minus 61, and similarly weight percent of solid will be 70 minus 61. So this you have to take 70 minus 61 divided by 73 minus 61. So like this you can determine that. So these are the some important questions which can be asked in exams related to any kind of binary phase diagram. So here we have just talked about the isomorphous binary phase diagram. So there are three different types of phase diagrams are available, like the isomorphous, in which the liquid and solid has complete solid solubility, and liquid solid liquid solubility. We have some eutectic and peritectic, eutectoid, peritectoid, like this. So if you have any questions related to binary isomorphous phase diagram, you can uh, reach out us by using Instagram or Facebook, or you can write your question in the comment section. So thank you so much for watching this video.